Hello, hope everyone's doing well. This is lesson 1.2.2. Last lesson on 1.2.1, my previous video, I made a video on reflections, and that's the first of the three transformations that we are learning in this chapter. And so in this lesson, our second lesson is going to be talking about the other two, specifically rotations and translations. So just a quick recap again, the three transformations that we're learning in chapter 1 are reflections, rotations, and translations. And as you are working on this, of course, if you want to know the actual definition and you want to take notes, you can always take notes by clicking on these vocab words. So if I click on translating here, it gives you a more of a clear definition. Obviously, it's covered by my words that I wrote, but you can always take a look at this on your own. So we're going to look at 1-59 here, 1-60, and then 1-61 as well. And then hopefully you're able to do 1-62 after going through these three questions in particular. So this might take a little bit of time, but let's go ahead and do this together. So as Amanda was finding reflections, she wondered, what if I reflect a shape twice over parallel lines? Investigate your question as you answer the questions below. So we're going to have a resource page, which again, if you flip over to the next page in your packet, you should be able to see it. You can also use the e-tool if you just want to use the Chromebook, which is completely fine. And so our goal is to see what happens when you reflect this triangle ABC along this line N and this line P. And so I'm going to go ahead, open this up. Zoom in a little bit, and I need to pull up my web paint one more time. And so we're going to stay on this sheet for a little bit. So 1-59, I'm going to make some reflections here. So to start, if we notice, we have these 3 points, A, B, C. It says to reflect it to make triangle A apostrophe B apostrophe C apostrophe. Now in math, whenever you have those little apostrophes, as it's written right here, we call that prime notation. That's prime notation. So with prime notation, you're basically making a new point. And so rather than saying DEF or another ABC, we write it as prime notation because those new points are transformed from the original points ABC. So I'll give you an idea as to what I mean. To start, I'm going to start with point A. Now, just like the last lesson, I'm going to count how far point A is from the line. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 units away. So I'm going to go 9 units to the right from the line. 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here is going to be point A. I'm going to erase that. I believe it was right there. So point A prime is going to be there. Point C, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units away. So right there is going to be point C. And specifically point C prime. Now, point B is only 3 units away, so I just need to go 1, 2, 3, and my point right there. So that's point B prime. And so the last step is to make my triangle. So I'm going to use the line tool, my web paint, to try to make straight lines. In class, try to use rulers whenever you can, just so that you can get those straight lines as well. So it should look something like this. But now it's being reflected one more time across this line P. So we're going to do the same process. Point A here is 1, 2, 3, 4, 5 units away. So I'm going to go 1, 2, 3, 4, 5. Put a point here. Now, if you notice, for the second part, it's saying to write it in the form triangle A double prime, B double prime, C double prime. So whenever you have however many apostrophes you got, that's how much we say. So in this case, it is 2 apostrophes, so we call it double prime. A double prime, B double prime, C double prime. Just a fun fact, if you were to keep going, And where you were to add another one, this would be A triple prime, B triple prime, C triple prime. However, after that, we don't want to write too many apostrophes, so they just go A to the 4, B4, and C4. So that I don't think will come up in this class, but just to let you know. Anyway, ignore what I said. And so that's where point A double prime is going to be. Point C now is 3 units away, so I'm going to go 1, 2, 3. It's going to be right there. C double prime, and then lastly B. Another way to think about it is just figure out how far B prime is from C prime. So B is 1, 2, 3, 4, 5, 6, 7, 8 units away. So I'll count from C prime double prime. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to count one more time. I think I messed up. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so right there. So B double prime. So now use my line tool to congregate these lines. And so this is going to be our finished product. Now, just to refer back to the original question, it's asking for part B, compare the original triangle ABC with the final result A double prime, B double prime, C double prime. What single motion would change the original to the newest picture? So how would we get from here to here? A lot of students said in class that we would slide the triangle over because all we're doing is we're moving this over here, right? It looks exactly the same as the original. It's just in a different position. This is what we call translation. And then it also says that in part C. So again, this is a translation. We're moving the triangle and we're just moving it in a certain direction, whether we move it right, left, up, down. So that's what a translation is. Okay. Now, again, going back to the lesson, part C. It looks like I could have just slid triangle ABC over, which is true. Sliding a shape from its original position to a new position is called translating. For example, over here, the ice cream cone at right has been translated. Notice that the image of the ice cream cone has the same orientation as the original. That is, it is not turned or flipped. What words can you use to describe a translation? Well, we can say slide. We can say move. You can think of others. So how will we describe this one here? Well, in this case, the ice cream cone moved up and then to the right. That's the way to say it. Now, again, for assessments or for homework, I'd like you to get used to the vocab. Instead of saying slide or move, try to say translate. Okay, try to say translate as our formal vocab. Okay, and then lastly, part D, what is the difference between transformation and translation? So remember, at the beginning of class, or really beginning of the lesson, I should say, transformations are the things that you do to a shape. So you reflect it, you can translate it, you can rotate it. However, translation is specific. It's a specific translation, and transformation. And what we do is we move something, we slide something. So translation is specific, transformation is very general, because there are 3 transformations that we've learned in this chapter. And we're going to talk about rotation next. Okay? All right. So I'm going to delete this. We're going to move on. 1-60. After answering Amanda's question in problem 1-59, her teammate asks, well, what if the lines of reflection are not parallel? Is the result still a translation? So we're going to go ahead and do this now on the next question here. Okay, I'm going to clear this. So first, visualize the result when triangle EFG is reflected over V, that's the vertical line, to form triangle E prime, F prime, G prime. And then that new triangle is now reflected over this diagonal line to form E double prime, F double prime, G double prime. And we're going to go ahead and draw that. So same process. I see point F. It is 3 units away. So I'm going to go 1, 2, 3 units to the right of the line. Okay, F prime. G, I believe, is 8 units away. It's the same triangle as up here. So we got 1, 2, 3, 4, 5, 6, 7, 8. So right here is going to be G prime. And then lastly, E. Another way that we can think about E is it's 2 units to the right of G and 3 units above G. So I'm going to go with the opposite. I'm going to go 2 units to the left, but then still go 1, 2, 3 above because it's a reflection. So we got E prime. And again, if you don't understand how I'm doing it, you can always just count and it'll always work. So I'm going to make the lines. Go from here to here, here to here, and then from here to here. All right, so that's the first reflection. But now I need to reflect it across the diagonal line. Now, hopefully if you remember and you watch lesson 1.2.1, the way that I like to do it is I just go straight down to the line of reflection since it's above it, and then to the right. Okay, again, I go down and then to the right. So starting with G prime. G prime is 3 units above, so I'm going to go 3 units below, and then immediately go 3 units, 1, 2, 3, to the right. Just make sure I get my eyes right. So we got G double prime right here. E is 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go 1, 2, 3, 4, 5, 6. Oh, see, hold on. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Right there. So E double prime is going to be here. And again, just to finish it up, you know that G prime is 8 units away from F prime. So you can go ahead and do the same thing, but go down instead. So 1, 2, 3, 4, 5, 6. Excuse me. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, I believe. Should be 8 units. And so that's going to be F double prime. So once again, let's go ahead and make our lines here. And so if you notice, it looks a little bit different. So going back to the original question, is the final image a translation of the original triangle? In other words, to get from EFG to E double prime, F double prime, G double prime, is that a translation? Well, remember, translating is only moving or sliding an object. But going from here to here doesn't look like it's a slide. So it's not a translation. Instead, it's turning, right? It's turning. And this is specifically what we call a rotation. It is a rotation. Okay. And the way that we sort of define this rotation here in part B, if you notice here, the original shape's getting turned or rotated, right? So the ice cream, instead of moving, it's turning. And this is the important part here that I want you to remember. In part A, the center of rotation is at point P. Point P is right here. This is the center of rotation as to which this triangle is rotating by. So again, this is your center of rotation. Okay. So with that in mind, where the lines intersect, line V and line W, that's where the center of rotation is. Okay. So that's how rotation works. Now, one observation I do want to make is, if you notice again, this is when the lines are non-parallel. So when you have non-parallel lines of reflection, it makes a rotation. Okay? For part 1-59, when you have parallel lines of reflection, again, what do we say that this transformation was? It is a translation. Okay? So parallel lines of reflection, like up here in 1-59, it makes a translation. When it's non-parallel, meaning they intersect, we're going to have a rotation. And the center of rotation is where the two lines intersect. So with part C, this question helps a lot when we do have tracing paper. So I'm not going to be able to explain this as best as I can. I will give you the finished product just so if you're trying this on your own, you can see what it looks like. So I believe 1, 2, 3, 4. And here. And that is 1, 2, 3, 4. Bam and bam. So the finished shape, when you rotate it counterclockwise 90 degrees, should look something like this. Okay. It's going to look something like that. And it's rotating about this point Q here. So with tracing paper, what I would do is I would put my pen or pencil directly on Q. I'd press it pretty hard, and then I would shift my tracing paper, and I'm rotating it. Think about 90 degrees like it's a quarter turn. And then 180 degrees is a half turn. But please, please, please make sure you know which direction you're going. I will give you the arrow in general, but hopefully for the second assessment for chapter 1, you don't need that. And all you need to do, if you don't remember what clockwise or counterclockwise is, just look at the clock, look at the second hand, and you'll see which direction it's going. That's clockwise. The opposite direction is counterclockwise. Okay. All right, so that is 1-59 and 1-60, rotation and translation. So now, looking at 1-61, this is prime notation. So we're going to take a look here. Because if you notice, for the first part, this is showing what a translation would look like. All it's doing is sliding from this square to the right. But it's still a new square. Even though the same shape, the position is different. So that's why I need to rewrite it as A prime, B prime, C prime, D prime. Now I'm going to look at part A. What transformation is happening here? How do we get from this one to this one? So think about it. And it does show, can you rotate or reflect the original square to make the letters correspond as shown? Well, let's think about it. If I rotate this, it would make sense, since if I were to do a little 90-degree turn, A would go here and C would go here, which makes sense because the new C is over here, new A is over here. However, B would rotate to where C was. But if I were to do that, well, this is D prime. That's not B prime, right? So this is not a reflection or a rotation. This is going to be a reflection. This is a reflection, and it's specifically rotating up somewhere halfway between these two squares. So that's going to be the line of reflection. Okay. This one you are not able to rotate. This is not possible. Now, part B, this time, ABCD is rotated 180 degrees about this point. I want you to copy this diagram on your paper. Label the vertices of the image square on the right. The image is the new picture. So if we're rotating at 180 degrees, once again, 180 degrees is a half turn. So let's think. If I'm starting with point A and I'm rotating at 180 degrees, if I start on the top here, a half turn is right here, right? So a half turn, in this case, when we think about a square, where's the halfway turn? It's right here where C is. So my new point A is right here. But again, this is a transformation. So I need to label it with prime notation. So this is A prime. And I'm going to keep going in this clockwise order here. So A prime is there, B prime's here, C prime's here, and D prime's there. Okay. So hopefully that makes sense. Again, whenever you're working with any sort of question, if you're making a transformation, make sure that the finished product has prime notation. Okay. So hopefully you're able to describe 1-62 on your own. Again, it's going to be a mix of two transformations. If you look at it, we're going to have to probably move it. The question is, do we rotate it or do we reflect it? So I want you to think about that. Do that on your own. If you want to check in with me, it's great. But hopefully this does help. Let me know if you have any questions, and I will see you later.